Okay, this is number 19 on the final review. So this is a spring with a rest length of 10 centimeters, stretches to 24 centimeters when the 5 kilogram mass is placed on it. So X initial is going to be 10 centimeters, which needs to be changed to 0.1 meters. X final is 24 centimeters because that's where it's being stretched to, which again changed to meters, 0.24. And then the mass placed is 5 kilograms. And then we want to figure out what the spring constant is. So we place a mass on it and we stretch an object. So the only way to actually place a mass on a spring and result in a stretch is to have a vertical spring set up. So initially you have the spring hanging by itself with a length of 10. Then you have a spring that's totally stretched out. It's a terrible drawing, I'm sorry. That is 24. So that means that the difference in their lengths is causing it to stretch. You know, it goes from 10 to 24. It's vertical, so the force of gravity on the block is what's causing the object to stretch. So that means that the gravitational force of the block is equal to the elastic force of the spring. So equal and opposite, one pulls up, one pulls down. Force of gravity is mass times gravity. The elastic force is negative k times delta x. Now, if you look at this, you're going to end up with a negative, but technically gravity is pointing down, so that should be negative, which means when you have both negatives, they are technically irrelevant. They could be both positives. So you have mass times gravity equal to k times delta x. Now, we don't have delta x. What we have is x initial and x final. So the problem's looking for the stretch. So we have to figure that out. And the formula would be delta x is x final minus x initial, which is 0.24 minus 0.1, which is 0.14 meters of stretch. So this spring is causing it to stretch about 14 centimeters when you put the mass on it. So from here we know all the information. We've got mass, we've got gravity, we've got delta x. So we plug everything in that we know. 5 times 10 is equal to k times 0.14. So 50 divided by 0.14 is how you're going to find your spring constant of 357.14 newtons per meter. Now what that tells you is that this particular spring would require 357.14 newtons of force to stretch it 1 full meter. This problem, we have 50 newtons of force, and it only stretches it 14 centimeters, or 0.14 of a meter. So 357.14 is the spring constant for that particular spring.